rate of change. You should have heard this before. Rate of change, we know it's slope. It's the difference between the y-coordinates and the difference between the x-coordinates. We know that slope is m. M is rise over run. So what we're doing is we're finding that rate of change between the y-coordinates on the top and the x-coordinates on the bottom. Slope formula can be used to find the constant of change in a real-world problem. We talk about constant. That's something that's not going to change. In other words, if it's a straight line, our slope is exactly the same. If it's a curved line or a quadratic function, we know that there isn't a constant. That slope will not be the same. So when traveling on the highway, drivers will set the cruise control and travel at a constant speed. This means that the distance traveled is a constant increase. The graph at the right represents such a trip. The car passed mile marker 60 at 1 hour. So here we went time. It's important to pay attention to the labels. So time was 1 hour right there. And then mile marker 180 at 3 hours. So there's mile marker 3. So 1, 2, and that was 3. Okay, we know that we're going 60 miles here. That was mile marker 60. Here's mile marker 180. So we can actually find the slope of this by doing a right triangle, but since this is real life, we can also use the numbers that have labels. We know I'm going from 60 to 80. We know that distance is my y-coordinate. How do we know that? Because they're giving us labels. They want miles per hour. We know miles is on the top, and since we know that rise over run is our slope, that must mean that the y's have to be on top, which is why distance is on the x or the y-axis, and time is on the bottom, so that has to be on the x-axis. So we know where to put our labels based on the real life label they're giving us. So I'm going from 60 to 180. That's 120 miles. I'm going from 1 hour to 3 hours, so that's 2 hours. So 120 over 2, we know from the work right over here is 60 over 1, so I'm going 60 miles an hour. If a car passes mile marker 100 in 2 hours and mile marker 200 in 4 hours, how many miles per hour is the car traveling? Well, let's do a quick graph. Okay? So, we're not going to have any negative miles or negative distance, so we know that we can label our coordinate graph using this, miles per hour. Miles is first, hours is second. We know that slope is rise over run. So we know that that's the difference of the y's over the difference of x's according to our slope formula. So that must mean that miles is on our y-axis and hours is on our x-axis. So that helps us with our graph. So, mile marker 100 in 2 hours. So we know this is 1, 2, 3, 4, 5 hours, and we'll count this as 50, 100, 150, 200, and so forth. So we're counting by 50s, counting by hours. So I pass mile marker 100 in 2 hours. There's my point. 2 hours, and there's 100. Okay, then I go past mile marker 200 in 4 hours. Well, here's 4 hours right over here, and mile marker 200 is right there. So then this is my graph of my travels right there. Obviously, this would be right over here because we started out right there. So I want to find my miles per hour. So we know that this is 2 and 100 for my x and y, over 2, up 100. We know this is 4, 200. over 4 hours, up 200 miles. So now all I have to do is think of my slope formula. Okay, how far did I go? Well, 100 to 200 means I went 100 miles. 2 hours to 4 hours means I took 2 hours to do it. So now I have to simplify that to 50 miles per 1 hour. If I don't put a 1 there, it's assumed. Okay? And 50 miles per hour. If a car passes mile marker 90 in 1.5 hours and mile marker 150 in 3.5 hours, how many miles per hour is the car traveling? So here's how I would solve this. This is what I hope you get out of these notes. First of all, I have to know my rate of change and how it's written. Rate we know is a fraction with two separate labels. So miles per hour means miles on top, hours on the bottom. Okay, miles on the top, hours on the bottom. Now, I have my two different points of destination, let's say. So here's my graph. Okay, we know that miles is on top, and that has to be our y-axis. We know hours is on the bottom, that has to be our x-axis. So we have 1, 2, 3, 4, 5, 6 hours, and we have, let's do 50, 100, 150, 200, 250, 300, etc. So 50, 150, 250, 1, 2, 3, 4. You don't have to put all these if you understand what I'm trying to explain. I'm just plotting the points now. So I passed mile marker 90 in 1.5 hours. So here's 1.5 hours right there. And I passed mile marker 90, which is about right here. And let's put those coordinates. 1.5 would be our x, because that's hours. And 90 would be our y, because that's miles. Okay, then I passed mile marker 150 in 3.5 hours. So 3.5 hours is right here. And 150 is right there. So that point would be 3.5 hours and 150 miles. We know then that our graph would go between there. That's how far we traveled. And if we had a correct graph, this would continue probably out to our origin. And if we continued on this, we could tell where we were going to be after 5 hours, 6 hours, 7 hours, etc. You kind of have an idea that maybe, the space shuttle or the rockets use something like that, since they don't have markers up in space. So how do we figure out miles per hour? Well, we do our slope formula. So again, our y minus our y, our x minus our x. They just happen to be real life. So let's take our 150 and subtract the 90. That'll tell us how far we went. You should be able to do that in your head. I went from 90 miles to 150. Hopefully you already said it's 60 miles. Okay? Then we went from 3.5 hours to 1.5, or backwards. I'm doing it. So remember, you got to go in the same order. So that's 2 hours. So I went 60 miles in 2 hours, which means I went 30, and then we have miles on top and hours on the bottom. 30 miles per hour. Number 2, if a car passes mile marker 220 after 1 hour and mile marker 400 in 4 hours, how many miles per hour is the car traveling? So this time I'm just going to sketch it. So we know that it's miles per hour. So that's the first thing. I need to know where my axes are at. Miles per hour. So miles is up here. Hours is here. So I'm just going to use this sketch of a coordinate plane to help me. So I know that after 1 hour, I went 220 miles. 50, 220, right there. Okay? So 1 hour, 220 miles. 1 hour, 220 miles. So those would be our coordinates. Okay, then I went 4 hours, 1, 2, 3, 4 hours, and I went 400 miles. So 50, 100, 152, 253, and I can extend this, no big deal. adding a line, sorry. Okay, I'm just using this for a sketch. So I'm going to actually bring it down a little bit. So 50, 100, 150, 200, 250, 300, 350. So there's our 400 right there. So 4 hours, 1, 2, 3, 4 hours, I went 400 miles. And I'm just sketching it so that it's easier for when I write this down, I understand how it looks on the coordinate plane. 1 hour, 220 mile marker. 4 hours, 400 mile marker. So I'm actually trying to find the distance between these two. So we know that I can find rate of change. I always go back to rate of change is your slope. We know slope is rise over run. We know rise over run is your difference of your y's and your difference of your x's. So in this case, the y's are a mile, so I have 400 minus 220. And our x's are our hours. I have 4 hours minus 1 hour. So I have 400 minus 220 is 180. 4 minus 1 is 3. Simplify. 180 divided by 3 is 60. And I already know my label has to be miles per hour. So I traveled 60 miles per hour. A driver sets the cruise control at 70 miles per hour. After driving 3 hours, he passes mile marker 320. In 2 hours, what mile marker will he be passing? Okay, so let's go ahead and make our little coordinate plane. So we have, again, miles per hour is what we're dealing with. So miles on the top, hours over here, so that's our y's. These are our x's. So 1, 2, 3, 4, 5, 6, 7, etc. And I have 320, so we'll go 50, 100, 150, 200, 250, 300, 350, 400. Okay? All right. After 3 hours, he passes mile marker 320. So we know there's 3 hours. Here's 320. So 3 hours, mile marker 320. I know that I passed something in 2 hours. So if I go backwards, somewhere along here, this line, okay, from when I started out at the very beginning, somewhere along here at 2 hours. So if I actually do my graph using kind of the intervals here, okay, I could almost estimate this. So somewhere up here, I bet it's somewhere around 200 and some miles, right at that spot. Okay, but that's just an estimate. I don't really want to do it that way. Now, I know I'm going 70 miles an hour. So, I have another point somewhere here. We know this is going to be 2 hours, but we don't know the y coordinate. Remember it says, in 2 hours, what mile marker will be passing? So I'm just going to do my slope formula. Remember, y minus y, x minus x. So I have 320 minus this y. I don't know what it is. I do have 3 minus 2. And I know that this has to be equal to 70 miles per hour. So let's do the math that we can. 320 minus y over 1 equals 70 over, again, 1 miles per hour. So I need, this cancels obviously, and that's a 1 on the bottom, so I have 320 minus y equals 70. Okay, let's just solve it. Get the y by itself, so let's do a same change opposite. I have to get rid of the 320, so I do that. Let's make this. Negative 320 on both sides. They cancel. I'm left with negative y. Positive 70, negative 320 is a negative 250. The sign of that is negative. I need to make it positive. So I do it to one side, I do it to the other. So y is going to be 250. What mile marker? 250 mile marker. Now, I did it mathematically because tomorrow in class we're going to talk more about how we can look at this and through experience solve it. if you thought of this, if I'm going 70 miles an hour, from 2 to 3 hours, I know that's 70 miles difference. If I'm at 320, I think most of you would have been able to say, well, just subtract 70. But we're actually learning a little bit more how to solve equations. That actually looks like a proportion. Okay, which is a higher rate of speed? Well, we know rate of speed is like rate of change. It's just slope. So let's do our slope that we learned from the first part of this unit. Okay, that's a difference of 120. That's a difference of 120. That's a difference of 2. So we know that it's the difference of our y's over the difference of our x's. So 120 over 2 is 60. Again, just remember, rate of change, rate of speed, slope, they're all the same. So this would be 60 miles per hour. Over here, they're telling us that the distance equals 50 times t, or 50 miles per hour. Remember, y equals mx plus b? They just don't have a y-intercept because they're starting out at nothing. They're starting out from their home. So if I have a number in front of a letter there, that's your slope. So our slope is 50 here. Our slope is 60 here. So the rate of speed is faster right there. Based on the tables below, what is the rate of speed for family A? So let's look at family A. All right, so here I'm going from 10 to 226, so that's 216 miles. And then here I went 156 miles. This was 3 hours to go that 260 miles. This was 2 hours to go the 156. So it doesn't matter which one I use. Okay, we're going at the same rate of speed. So maybe they stopped here. Maybe they went, to a rest stop. So I'll use the 0 to 10 and the 3 to 226. So I went 216 miles, and it took me 3 hours. So that's going to be, 3 goes in there 72 times. So that's 72 miles per hour. So it says, based on tables below, what is the rate of speed for family A? So 72 miles per hour. Let's double check that. Good. All right. Monique earns $8 per hour for babysitting. Which equation represents the situation? Well, $8 per hour, so dollars per hour. Guys, that's the same as miles per hour in terms of rate of change. It's something that happens over and over and over again. It doesn't change. She suddenly doesn't earn $10. She suddenly doesn't get dock pay. She earns $8 every hour. So her total, let's say, money she earns, or dollars she earns, she gets $8 for every hour she works. Now there is no plus number over here because they're not giving her anything to start. So when she goes to babysit, she has nothing in her pocket. So if I tell you that she works 3 hours, the total amount of money she makes is 8 times 3 hours, which means she would make 24 hours. That's how we can use equations to help us. So if I look up here, which does it match? This one. I just use different letters. Ryan spends $20 per week out of his savings. So every week, $20 every week, 20 per week. He began with $300. So he spends this. So spends is what kind of number? It's a negative. I have to give it away. He started with a positive 300. So his savings, S, equals minus 20 every week, because he's going to get rid of it, but he started with a positive 300. So if you look, that's our answer. So we can take words and change them into equations. Okay? Which of these could represent a snack mix company that charges $7 for pistachios plus $3 shipping? So right off the bat, $7 per pound. Okay, so we'll just put per P. But I'm also going to have to charge you $3 to begin with, but I don't charge you more than once. So the total amount of charges equals $7 per pound of pistachios plus $3. So if we looked here, I can go ahead and I have to find a slope of 7. The rate of change is $7. Okay? So, what are we looking at here? Well, first of all, this is our y-intercept, right? Our y-intercept is when x is 0. Here x is 0, y is 3, so that's possible. And then I know my slope is 7. Okay? 3 to 38 is 35. 0 to 5 is 5. 35 over 5 is 7. So that matches. So we can use the knowledge we learned in part 1 of this unit to help on that one. Okay? If I went over here, that's a difference of positive 10. That's a difference of positive 10. 10 over 10 is 1. They're charging $1 for shipping. All right, that's like it's it. So hopefully you have notes on a sheet of paper. Basically, just listening to me. We're going to go over it more tomorrow, and we'll do some problems.